its graph. Okay? So first thing that we're gonna do, let's read our step number 1. Alright, Kendall, go ahead. Let's read our step number 1.
Identify any sign change on the parent function based from reflections horizontal forward.
Thank you, right? Again, a negative in front of the log means an x-axis reflection, right? A negative inside the parenthesis will be correspond to a y-axis reflection, right? So let's go back in here. This is number 48, okay? So what's log base 3 of x? How does it look like? A log base 3 of x looks like what? Let's see in here. Just a typical parent function of log base 3 of x. Y is equal to, go to functions, we go to calculus. Where's that calculus? Log with a base 3 of x. Are we good? So that's our parent function, right? Log base 3 of x looks like that, okay? 48, yeah. Comparing that one in here, so once again, this is the log base 3 of x. That's the parent function, okay? Let us now compare this and this graph, right? So this graph and that graph, is there going to be kind of like a reflection that happened? Is that an x-axis reflection? Like this one reflected along the x-axis? Or is it more of like a y-axis reflection? Or is it both? X and y-axis reflection. In short, it went x-axis reflection first and then y-axis reflection after. Which one? Just x-axis reflection. Very good, right? So as you may notice in here, this one actually, if you flip it along the x-axis, it's gonna look like what? Step 1, x-axis reflection, right? And as you may notice, it looks like what? And notice that this and that does look like the same. Are we good, guys? We good? So with that being said, where do you think is the sign change? Is the sign change in front of the log? Or inside the parenthesis? In front of the log, right? So number 48, step number 1. Okay, once again, our parent function is the following. F of x is equal to what? Log base 3 of x. With an x-axis reflection that we have identified, then we're gonna sign change the front, right? So that means you have now the following, all right? Negative log base 3 of x, right? Because of the x-axis reflection. Are we good? Yes, guys? Okay. Next now, let's read step number 2, right? Kate, go ahead.
Consider the movement of the vertical asymptote from y-axis as the
C value. Thank you. All right. So let's see. How did the vertical axis move from the y-axis? And that's going to be our C value. Okay. Again, with respect to the y-axis. All right. So where's the y-axis? This is your y-axis, right? Where's the vertical asymptote of this? Did it move to the left or did it move to the right? To the left. How many units to the left? Let's count. From here, this is the y-axis, right? 1, 2, 3, 4 units to the left. Are we good? Right? With that being 4 units to the left as the vertical asymptote for this one. We good? What's your C then? 4 or negative 4? Plus 4. Very good. So put in here, I'm going to color it green. The VA moves left 4 units from the y-axis, okay? From the y-axis. Hence, your C is equal to what? Negative log base 3. Inside in here is what? X plus 4. Very good. Right. Lastly, let's continue here. Step number 3, right? Let's read step number 3. Isaac, can you see it from there? Thank you.
Multiply resulting equation by A and solve this using y-intercept or any closing point.
Thank you, all right? Yeah. Any chosen point x1, y1. Whichever of those two is easier. Honestly, if the y-intercept is given exactly, it's easier to use that. But if not, then you just choose any chosen point along the graph. Are we good? Right, so let's see in here. Again, we're computing for that A, a possible one. Vertical stretch or vertical compression, right? So with that being said, I'm gonna put in here step number 3. I'm just gonna multiply this by 8, right? So here, negative or y is equal to negative A log base 3 of x plus 4. What is the best point to choose on the given curve, right? Actually, this point, right? What is that point in there? Negative 1, negative 3, right? So as you may notice in here, I'm gonna color it blue, this one. That point is negative 1, negative 3. Now you might be asking, Mr. Deal, why don't you want to use the y-intercept, right? Honestly, if you look into the y-intercept, it doesn't hit negative 4 exactly at negative 4, right? Notice that one, right? Okay. That's why we want to choose that one because it looks like it actually hits it exactly, right? So that will be your x and your y. Good? And you can solve from A, for A using that. So put it in here as follows. Again, at point negative 1, negative 3, right? So this is your x and this is your y. And we can solve for A using that, right? So put it in here. What's your y again? Negative 3. Right? So negative 3 is equal to negative A log base 3 of, what's this again? Negative 1 plus 4. Are we good, guys? Okay, so continuing this one, negative 3 is equal to negative A log base 3 of, what's this? 3, right? Well, what do you know about log base 3 of 3? Calculators, guys. What's log base 3 of 3? If the base and the number are the same, 1. Very good. That is correct, right? So this is basically just equal to 1. Well, just equal to negative A times 1 is equal to negative 3. And that's it, right? Your A is equal to what? Basically. Are we good, guys? Okay. So you got your A to be equal to 3. Based from the chosen point, negative 1, negative 3, right? Honestly, if the y-intercept is given to be exact value, it actually hits that point, we can use that one, but in here, we cannot, okay? It doesn't hit exactly that. Anyway, step number 4. Let's read this step number 4, okay? Angelina, go ahead, please.
Rewrite the equation and verify by graph.
All right, thank you. So what's our final answer? So the answer will be as follows. Y is equal to negative, what's your A again? 3, right? Log base 3 of x plus 4, right? So in short, an x-axis reflection, right? A vertical stretch by a factor of 3, right? When stretched by 3 units factor of 3, and moves left. The vertical asymptote moves left 4 units. In short, at VA equals negative 4, right? And again, let's verify if this graph is honestly equal to the graph that we are expecting it to be. Put it in here. What's this again? Negative 3. Is that 3? Right? Okay. Yeah. Log base 3 of x plus 4, right? Okay. Now, is this the same graph as what we saw a while ago? Well, let's see. Is the vertical asymptote at negative 4?
Yeah.
Yes. Okay. Did it hit the point negative 1, negative 3? Yes, it does. Right? So, as you may notice, this graph and the given graph from our worksheet are the same. Are we good, guys?